So now that we've talked about the power functions and what they look like, let's actually talk about what's called end behavior. So end behavior is what's happening to the graph. So it's the behavior of the graph as x approaches infinity and as x approaches negative infinity. Okay. So there's an example here that's already done for us. And so what we want to do is take a look at what's going on here. So as x approaches infinity, I'm going to zoom in just a little bit here. Now, as x approaches infinity, what we're looking at is this part of the graph, right? As x is going to infinity, what is our function doing? Well, the function is going up. It's increasing. So what we say is that f of x, that's the function, is also approaching infinity here, right? Because it's going to keep growing and growing and growing. It's just going to keep, getting taller and taller. The other half of the graph, okay, as x approaches negative infinity, so that would be from the origin to the left, okay, we want to look and see what's happening to the curve. So in this case, the curve is moving from the origin to, it's just dropping. So in this case, it is approaching negative infinity, all right? So this is what we're going to be focusing on for the end behavior. It's what's happening as x is approaching infinity and what's happening as x is approaching negative infinity. So you have to write both halves of the problem or both halves of the answer to cover the end behavior, okay? Now, what we're going to do is we're going to talk about some transformations here, okay? So we have odd degree power functions. We have even degree power functions. What happens when a is greater than 0? So a is going to be positive. A is less than 0. That means a is going to be some kind of negative value. What happens when b is greater than 0? So positive, and when b is less than 0, negative. So we're going to use what we know about our power functions to, what I would do is sketch a little graph here. So in this first one, and I'm just going to go ahead and fill in all the odd degree power functions first, okay? So in the first one here, if I draw myself a little sketch, right? If a is positive, and we're talking about an odd degree power function, our function is going to look something like that. It may not be exactly that, but it's close. And so now if we want to focus on the end behavior, all right, so as x approaches positive infinity, so positive infinity for x is going to be moving from the origin to the right, okay? I want to know what's happening to my function. Well, my function in this case is going to infinity, positive infinity. So in this case, we'll call it f of x. All right, I don't think there was a name for any of these. Yep, we'll just call it f of x. So f of x, whatever the function is, okay, is approaching infinity. But that's only half of our end behavior. So the other half is as x approaches, negative infinity, all right? So x approaching negative infinity is going to be from the origin to the left. And I want to look and see what my curve is doing. Well, my curve is dropping here towards negative infinity. If I give it long enough, it'll just keep going towards negative infinity. So f of x approaches negative infinity. Let me actually redraw that so you can see see the negative sign and the infinity. That was a pretty horrible infinity, but I'm going to go ahead and let that one be because it was better than the other ones I drew. All right. Just keep working my way down this list here. So a is less than 0, which means our a is a negative value. Okay. So that's going to take this power function, remember, and it's going to reflect it over the x-axis. So graphically, that would look something like this. Okay, again, it may not be exactly that, but for this particular problem, I don't need exact, I need the general idea of what the graph looks like. So now I'm going to take this graph and use it to talk about my end behavior. So as x approaches infinity, so that's going to be from the origin to the left. No, that's to the right. I'm shading the right thing and saying the wrong words. Imagine that. Let's see what's happening here with our curve. Well, our curve's dropping. And in this case, it would drop, and we would say that f of x is approaching negative infinity. Okay. And then we have the other half. So as x approaches negative infinity, f of x is going to be approaching, well, something. So x approaching negative infinity is going to be from the origin to the left. I'm going to say the correct word this time. And our curve is increasing, right? As we move away from the origin to the left, our curve is increasing, and it would be approaching infinity. Okay? So that's what happens when you deal with the a values. Let's talk about our b values here, all right? So b is greater than 0. This is going to mean that our b value is positive. Positive, spell the word correctly. Okay, so by the way, that was directed at me, not at you guys. All right, so if b is positive, that's just a normal power function curve. Nothing special about it. So this end behavior would be identical to this end behavior because the graphs are identical. All right, so I'm going to cheat just a little bit. I'm going to loop up this answer here. I am going to copy it and I'm going to paste it because it still applies. All right. As we start from the origin, we move towards infinity. That would be to the right. Okay. Our curve, actually, hold on a second. Let me match what I've been doing in the past here. So our curve here from the origin moving to the right, the function is increasing to infinity here, okay? And then if I look to the left, so from the origin to the left, the curve is dropping to negative infinity, okay? So that's what happens if b is positive. And of course, we've got one more here, and that would be if b is less than 0. So that's going to be negative. And we want to take this original curve, remember, and we want to reflect it in this case over the y-axis. So this piece in the lower left is going to move over to the lower right, and this piece in the upper right moves to the upper left. So graphically, it would look something like, I don't know what just happened. So let's, oops, nope, didn't want to get there. Hold on. Back to Notability. Apparently my Notability decided to quit because, well, you know, that never happens. Gotta love technology. All right, so let's see, back to this graph. So let's actually see if it'll work now. All right, so the graph would look something like that, which means that our end behavior is the exact same thing that we have here. So again, being just a touch lazy, I'm going to loop it, copy it, and then I'll paste it down here. So graphically here, as we move from the origin to the right, our graph is going to negative infinity. And then graphically, as we move from the origin to the left, we are going to positive infinity. Okay? So that's what's happening with your odd degree functions. So I'm going to go ahead and slide over to the other half of this, and let's see if we can't figure out the even degree functions. Okay? So let's see. First one, a is positive. So even degree function with a positive a value, it's going to be your quadratic that's kind of like concave up here. All right. And so when we look at this, what we might notice is that the function is pointing up in both sides. So our end behavior, as x approaches infinity, f of x approaches, well, let's look. So positive infinity here on the x-axis, and our graph is increasing. All right, it's going towards infinity. Okay, but if I look at the left side, so from the origin to the left, the graph is also increasing. Okay, kind of interesting. So as x approaches negative infinity, f of x approaches infinity. Okay, so that's our normal even degree function. Let's see if we can't look at what happens when a is negative. So we're going to take that same little curve that we did, but if a is negative, we're going to reflect this curve over the x-axis. So instead of upper left and upper right, it's going to be lower left and lower right. So function-wise, right, when we look at our end behavior, as x approaches infinity, f of x approaches, well, infinity this way, right? And our graph is decreasing. It's dropping to negative infinity. As x approaches, negative infinity, get the negative sign in there. Let's see what's happening. So negative infinity is going to be from the origin to the left, and our curve is, well, decreasing. So f of x is approaching negative infinity. So one of the things that you're going to notice about even degree functions is your end behavior will match. So this is approaching infinity, this is approaching infinity. Same thing, negative infinity. But your odd degree functions will always be opposites. So 1/2 of your function is going to be approaching infinity, and 1/2 is going to be approaching negative infinity. Now, order won't matter, but it's always going to be a mismatch for your odd degree functions. All right, last two here is what happens for your b value. If your b value is positive, that means you're going to have a normal concave up function here, which means I'm just going to loop the end behavior from this first one, copy it and paste it because it matches. Okay, so your curve in both cases, right, we're increasing to infinity here, and that's for x approaching positive infinity. X approaching negative infinity, we've got, again, positive infinity. And let's take a look about if b is negative, that's going to reflect over the y-axis, which means it's going to look identical to what we just did. So because your even degree functions already have that same symmetry, it's not going to change. So it's the same exact thing as the last problems. So as x approaches positive infinity here, your curve in this case is increasing. As x approaches negative infinity, your curve is increasing. Okay? All right, so at this point, I'm going to go ahead and close this video about end behavior. I believe there's a 4th page on here that's got some practice problems, and I will pop up a separate video with the answers to those practice problems. Let me know if you have any questions or concerns about power functions or about